Hey guys, today we are looking at 2.3, which is all about solving inequalities using multiplication and division. Very similar to chapter 1, we multiplied and divided on both sides to solve my equation. With my inequalities, I'm just going to be doing the inverse operation in order to get my variable isolated. There's just one little wrinkle that happens when we're multiplying or dividing on both sides of my inequality when that number is negative. So we're going to look at these two definitions first for our multiplication property of equality and our division property of equality, and just kind of look at what happens when I have positive numbers and what happens when I have negative numbers. So starting with this very first one, if we multiply each side of my equation by the same, we're going to start with positive numbers. If we multiply by the same positive number on both sides of my inequality, let's take a look and see what happens. I'm just going to be using a pretty simple inequality for our example here. If we start with 4 is greater than 2. That is a true inequality. 4 is greater than 2. So if we multiplied both sides by a positive number, let's just say we're going to multiply times 3 on both sides of my inequality, the new inequality I'd be left with would be 12 is greater than 6, which is still true. So in this one, when I multiply by the same positive number, the direction of my inequality stays the same. So the way we would write that in inequality terms, if A is greater than B, then A times C is still greater than B times C. Now let's take a look at what happens with a negative number. If I still start with that same inequality, 4 is greater than 2, but this time I multiply by a negative 3. What I end up with is negative 12 is greater than negative 6. 12, the digit 12 is bigger than 6 is, but if we look at it in terms of the negatives, when I multiplied by that negative number, negative 12 became a bigger negative number than negative 6 is, which in terms of our number line means it's further to the left, so negative 12 is actually less than negative 6. So when we multiplied by this negative number, by the same negative number, what we end up having to do in order to maintain that inequality being true, we actually have to flip the direction of my inequality. The inequality symbol is flipped. And that's, again, in order to maintain the truth of that statement. We could also start, again, if that, well, I'll do a different example with division. So here, that inequality is flipped. So the way that we would write this in my if-then statement over here, if A is bigger than B, then A times C, which would be a negative, let's even write that, A times negative C is now going to be less than B times negative C, if that number is negative. We have to flip that inequality. The same thing happens with our division problems. If I divide by the same positive number, the inequality stays the same. And the way that would look inequality-wise, if A is bigger than B and C is positive, then A over C, or A divided by C, is still bigger than B divided by C. But once again, the negative is a little bit different if I divide by the same negative number. So let's just start something, let's say negative 4 is less than negative 2. Which is true. Negative 4 is smaller than negative 2. It's further away from 0 on the number line. If I divided both sides of that inequality by a negative 2, I would end up with positive 2 is less than positive 1, which is not true, which tells me in that case when I divide by a negative, I also have to flip the direction of my inequality. I have to flip that so now 2 is greater than 1. So once again, dividing by a negative, the inequality symbol is flipped. So anytime you multiply or divide by a negative in an inequality, you just have to make sure that that inequality gets flipped. And that's the same regardless of whether it's less than, greater than, less than or equal to, or greater than or equal to. All 4 of those different inequality symbols, you just got to flip the direction that the inequality opens. Inequality-wise, sorry, I messed that down here. If A is bigger than B and C is negative, now A over negative C is going to be less than B over negative C. just formalizing it. All right, let's switch to green for some of these problems. And here you can tell there's a typo in mine, and I forgot to catch it before we did it, so we're just going to go ahead and skip number 1. There's supposed to be a variable here next to 3. But I'm not going to do all the problems that I have set up here on the worksheet. I'm just going to go through a couple of them to get you kind of used to it, so you see it a couple of different ways. So we're actually going to start with number 2 here. In my instructions, I didn't write them on here, but the instructions are just solve the inequality, graph the solution on the number line. It's going to be the same set of instructions for 90% of what we do in this chapter. All right, so for number 2, I have to solve that inequality. Right now, I've got -4 times p is less than 36. So right now, my variable p is being multiplied by -4. So we know the inverse operation of multiplication would be division. So if I divide by -4 on both sides, those cancel out. I'm left with p on the left side. I know that 36 divided by -4 is a -9. And now in this case, because I divided by a negative number, I have to flip the direction of my inequality. So now instead of less than, this becomes greater than. And that's my solution. P is greater than -9. So on the number line, I'm just going to start here because it's already visible. -9, -8, -7, -10, -11 would be 5 points on my number line. -9 is the boundary. It's going to be an open circle because it's just greater than. And here, depending on how you want to do this, I should be pointing to the right. My variable's on the left, so the inequality points the direction it should be shaded. You could do a test point. You can just look at it in terms of, logically, p is bigger than -9, so all of the stuff that makes that inequality true has to be bigger than -9. However you get the direction of your shading is up to you. Okay. All right, for number 3, it looks a little intimidating because it's a decimal, but I still have a number times my variable, so I have to make sure I'm doing division in order to get that by itself. So here I divide 1.8 on both sides. Now here, make sure you're careful because the thing that I'm dividing on both sides is positive. So I don't flip my inequality here, even though I'm dealing with a negative 5.4, because what I'm dividing by is a positive 1.8. I don't flip my inequality. It's only when you multiply or divide a negative number on both sides of your inequality that you flip the direction of that. So here, my 1.8 cancels. I just have m is greater than or equal to, because it's going to stay the same. And here, you'd grab a calculator to do this. It actually, even though it's messy looking numbers, you come out to a nice, clean -3 for your solution. 5.4 divided by 1.8 is 3. And that negative sticks around. So now again, on my number line, I'm just going to graph at least 5 points. Nope, I said 5 and wrote 5. -4, and that's -5. Here it's going to be a closed circle because it was or equal to at the boundary. And again, shaded to the right because it's greater than or equal to. All right, I'm going to go ahead and skip this one. Let's jump on down to number 5. Now we're going to get into solving some inequalities with multiplication. So here, again, we notice something is happening to my variable. I want to do the inverse operation for whatever is happening to my variable. In this case, y divided by -8 means I'm going to have to multiply both sides by -8, because that's the opposite of dividing by -8. So now y by itself, because I'm multiplying by a negative number, I have to flip my inequality, -16. So on my number line, I've got -16, -15, -14, -17, -18 gives me 5 points. It's going to be an open circle at the boundary since it was just less than. And in this case, because it's less than, it's going to the left. Or again, any of those other alternate methods of figuring out which direction to shade. Let's skip. Let's do one of these. Let's do 7. So for number 7, here I'm taking m divided by 7 is greater than -14. So here I have to multiply by 7 on both sides in order to get my variable by itself. So in this case, again, I'm multiplying by a positive number, so my inequality stays the same direction. Even though I have a negative in my problem, I'm not multiplying by a negative number, I'm multiplying by a positive. So -98 is what I end up getting. And again, feel free to use a calculator. Negative 14 times 7 is negative 98. So now I'm going to go negative 98, negative 97, negative 96, negative 99, negative 100. Notice here I added more hash lines in my number line, but that doesn't necessarily need to be there. I can not use all of mine because I don't want to try and scrunch my numbers together. So you can see I just did every other hash line for my number, which is fine. As long as you're scaling it appropriately, you can do whatever you want. So here, open circle at negative 98, and it's greater than, so I'm going to the right. Next section here, still technically same process. We've done some of these in the past when we were solving equations where we ended up multiplying by the reciprocal in order to cancel out what I have. Because here, looking at what's happening to number 9, I've got h is being multiplied by negative 2/3, and that's supposed to be less than negative 6. Technically, you could go through here and divide by negative 2/3 on both sides because h is being multiplied by negative 2/3. But how we divide a fraction, it gets messy real quick. And technically, multiplying by the reciprocal is the same thing as dividing by a fraction. So instead of going through and writing these as a bunch of division problems or anything like that, what we can do, I'm going to rewrite this just down below. I'm not changing anything. I'm just giving myself some space to write. Instead of dividing by that fraction, what we can do is multiply both sides by the reciprocal. So again, reciprocal just means we're flipping that fraction over. So here, what we'd have to do is multiply both sides by a negative 3/2, right? It's negative 2 over 3 right now, so what we want to multiply by was positive 3 over negative 2. And I have to do that on both sides. 3 over negative 2. Because now my negative 2's, they cancel. My positive 3's, they cancel. So I'm just left with h. I did multiply by a negative number here, so I'm going to have to flip my inequality to be a greater than now. And then on the other side, it's kind of up to you on how you want to do this, how you like thinking about it. These negatives are going to cancel each other out. 6 times 3 is 18. Divided by 2 should be a positive 9. Or if you're a reduced person first, 6 over 2 just becomes, this is a 3, this is a 1. 3 times 3 is 9. Whatever floats your boat and makes you happy. But that's the general process for getting these variables by themselves. That's how we would handle multiplying by the reciprocal. I'm not going to graph this one because you guys at this point should know how to graph it. I want to do one more problem like this just by itself. All right, so for number 10, now we've got negative 3/4 times w is greater than or equal to 12. So again, if I'm doing that same process, I'm going to be multiplying 4 over negative 3 on both sides because I'm just taking that original fraction and just flipping it over. When I do that, my negative 3's cancel, my 4's cancel, I've just got w. It was a negative number I had to multiply by, so less than or equal to. And then here, 12 times 4 would be 48, divided by negative 3 is a negative 16. Or once again, if you're a reduction person, 12 divided by negative 3 would be a negative 4, and negative 4 times positive 4 would be a negative 16. However you want to get there, whatever floats your boat and makes you happiest, or in some of our cases, whichever method confuses us less, go with that one. All right, for our last part here, application problems. I've just got 2 of them that we're going to go through together. Just, again, getting these set up and solved is going to be important for us in the future. Before we start this first problem, I once again want to remind you our DRT equation, or D equals S times T. So here, distance is equal to a rate times a time. And specifically for speed problems, you guys have probably seen these in physical science. If you're in physical science, speed times time is how you would find the distance that you travel. That is going to be important here for this one because in this we're taking a trip to a museum that's 190 miles away. We know that the rate the bus can travel at, the speed the bus can travel at, is 55 miles an hour. We want to figure out at least how many hours should your class plan for the trip to the museum. This is, again, assuming how early should we leave? How much time do we need in order to get there? So in this case, if we're going to model d equals r times t as our inequality, we know that the rate that we can travel at is 55 miles per hour times how long it's going to take to get there, so times t. That tells me how long the trip will take based on the rate. We know that it's 190 miles away. So what we need to figure out is what inequality would happen between those two. Now, ideally, it's going to be exactly equal to 190 miles, right? That's the distance that is away. But if I have to throw an inequality in here, based on the route that I take, if 190 miles is the actual distance from our school to the museum, that is the shortest route possible to get directly from here to there. So the route that we actually travel, depending on what roads we're taking, could be more than 190 miles, right? If we go, south and then east, we're going not a direct path to it, but we're taking some, more cardinal directional roads and stuff. It might be a little bit longer of a trip. Maybe it takes us 200 miles to get there instead of 190 miles. But we know that it's not going to be any possible to get there in fewer miles because 190 is the exact distance from our school to the museum. So that's the inequality you have to set up for that one. 55 times t, which would be the time it takes to get there, has to be greater than or equal to 190. So to solve this, as you can see, I'm multiplying t by 55. I just have to divide 55 on both sides to get my t by itself. You'll need a calculator for this because what we end up with is that t is greater than or equal to 3.45. Repeated, actually. Hours. I need to put my units in there. Can't forget. All right, last one. The long distance phone company, because those still exist, is offering a special rate of 6 cents per minute. Our budget for the long distance phone calls is $25 for the month. How many hours, at most, how many minutes of long distance can you use for the month with this rate? We know that we're charged 6 cents per minute. So 6 cents times the number of minutes you're on the phone is what you're charged. That's going to be the cost of what your bill is. If we have $25 for the allowance, once again, we could be charged exactly $25, so it could be equal to. But we know that we don't have any more than $25 in order to spend on this bill. So the amount that we're charged is going to have to be less than or equal to that $25. And that's the equation that we end up having set up. So once again, to solve this, we're going to have to divide by 0.06 on both sides. So we end up with being able to talk for 416.6 repeated minutes and still being within that $25 allowance. All right, so that's it. Your homework that you guys will have time to work on in class on Tuesday is page 71, 4 through 28, just the evens. As always, I will always suggest watching this multiple times, asking questions when you're confused, and just coming ready with those questions during class. Just make sure you guys are reaching out and asking for help when you need it. Have a fantastic day.